Quadratic equation. The equation of a curve is y equals to 4x squared plus 20x plus 6. Express the equation in the form y equals to ax plus b squared plus c, where a, b, and c are constant. So we have y equals to 4x squared plus 20x plus 6. And we want to find the completing the square form. So we need to change the equation into the completing the square form. So we can factorize the expression into y equals to 4 and then x squared plus 5x plus 6. Yeah, we are focused on the first two terms. So that means we can do the completing the square of this form. So we prepare the room. It is 4, the bracket, plus 6. And now for the completing the square, I prepare the bracket and minus. So this is x squared, so this is x. Plus 5x become plus 5 over 2. Always divide the coefficient of x by 2, yeah? And then minus the given number square. So we will have y equals to 4 x plus 5 over 2 squared minus 25 over 4 plus 6 equals to, we expand x plus 5 over 2 squared minus 25 plus 6 equals to 4x plus 5 over 2 squared minus 19. So this is the answer. B, hence solve the equation of 4x squared plus 20x plus 6 equals to 45. So we can use the form that we have in the first question. 4x plus 5 over 2 squared minus 19 equals to 45. So 4x plus 5 over 2 squared equals to 64. That means x plus 5 over 2 squared equals to 16. And then we root it equals to 4, or x plus 5 over 2 equals to negative 4. So x equals to 4 minus 5 over 2 equals to 3 over 2, or x equals to negative 4 minus 5 over 2 equals to minus 13 over 2. Yeah, these are the solution of the equation. Sketch the graph of y equals to 4x squared plus 20x plus 6, showing the coordinates of the stationary point. You are not required to indicate where the curve crosses the x and y axis. So according to the form that we have, y equals to 4x plus 5 over 2 squared minus 19. From this form, we can have the stationary point, or we call it as a vertex. Now, from this equation, we can draw the quadratic graph. If we see that this form So from this equation, we can find the least value of the function. How do we find that? If you see from the expression, the number that can be varied is in this part, x plus 5 over 2 squared. Because this part is being squared, so that means the least possible value that the equation can have is equals to 0. Because if you have the number less than 0, for example, -1, it being squared and equals to 1. So that means the least value is only 0. So when we have that value as 0, we can have 4 times 0 minus 19. So equals to -19. That means this will be the minimum value of the function. And this minimum value is taken when x plus 5 over 2 is equals to 0 from this part. So it's happened when x equals to -5 over 2. This x equals to -5 over 2 called as line of symmetry. So that means we can draw it this is x, this is y, then I add the line here. So we have the minimum value. The coordinate of the minimum value are -5 over 2, -19. So it's -1, -2, -3, -4. So -5 over 2 is around here, and -19. So -19 here. So the minimum value will be here. And because this is a minimum, so it will be facing up. So the sketch will be like this. The stationary point here is the coordinate of the minimum point, -5 over 2, -19. Next, number 2. Solve the equation 3x plus 2 equals to 2 over x minus 1. To solve this equation, we have to do the cross multiply. 3x plus 2 multiplied with the x minus 1 should be equals to 2. And then we can do the expansion here. So 3x squared minus 3x plus 2x minus 2 equals to 2. And we can reduce this expression into the quadratic equation. So 3x squared minus x minus 4 equals to 0. Can we factorize this one? Let us try. The x. How do we make into -1? So it is 4 and 1. So -4 plus 3 equals to 0. So that means here x will be equals to 4 over 3, or x will be equals to -1. That's it. Number 3. The equation of the curve is y equals 2, and the equation of the line is y equals to x minus 8, where k and a are constants. Given that the curve and the line intersect at the points of x with x coordinates 0 and 3/4, find the values of k and a. That means 0 and 3/4 are the intersection point between the curve and the line. So we can construct the intersection point equation first. So we can make the y of the curve and the line the same. So it's 4x squared minus kx plus half k squared equals to x minus 8. So when we put x equals to 0, this will equals to 0 minus 0 plus half k squared equals to 0 minus 8. So half k squared equals to negative 8. This is the first equation. And when x equals to 3/4, that means 4 times 3/4 squared minus k times 3/4 plus half k squared equals to 3/4 minus 8. So I can have 9/4 minus 3/4k plus half k squared equals to 3/4 minus 8. So from the first equation, half k squared equals to negative 8. So I can just replace this into here. So it's 9/4 minus 3/4k minus a equals to 3/4 minus 8. I can cross a, and then I can simplify. Negative 3/4k equals to negative 6/4. So k equals to 2. When k equals to 2, so that means half of 2 squared equals to negative 8. So a is negative 2. Given instead that a equals to negative 7/2, find the values of k for which the line is a tangent. So that means tangent is one intersection point. So we have to simplify this equation first for b. So for intersection point, it's for x squared minus k. The k is negative. Oh, a is negative 7/2. So minus kx plus half k squared equals to x minus negative 7/2. So that means for x squared minus kx minus x plus half k squared minus 7/2 equals to 0. And then we can classify the term for x squared minus k plus 1 x plus half k squared minus 7/2 equals to 0. So we have to bring this into the general equation. Ax squared plus bx plus c. So this will be a, this will be negative b, and this all will be c. It says that the line is a tangent, so it has only one intersection point. So that means we can see from the discriminant is equals to 0 for a tangent, one intersection point. So that means b squared minus 4ac equals to 0. So the b is k plus 1 square. I can just put negative here, but because negative square is positive, so it will have the same answer. Minus 4, a is 4, and c is half k squared minus 7 over 2 equals to 0. So we expand this, k plus 1 square minus 16 over 2, 8k squared plus 8 times 7, 56 equals to 0. So this is k squared plus 2k plus 1 minus 8k squared plus 56 equals to 0. Simplify. Negative 7k squared plus 2k plus 57 equals to 0. Or I can multiply it by negative 1, 2k, 7k squared minus 2k minus 57 equals to 0. Can we factorize this? So this is 7k, this is k. How do you make the 2? So 57, it's 19 times 3. So negative 21 plus 19. So it's negative 2. So k is negative 19 over 7, or k equals to 3. So these are the values of k for which the line is a tangent to the curve. Next, a curve has equation y equals to kx squared plus 2x minus k, and a line equation kx minus 2, where k is a constant. Find the set of values for k for which the curve and the time do not intersect. Do not intersect means there is no intersection point, no solution. So we can say the discriminant of this system of equation will be smaller than 0. So we have to make the equation first. So the y will be equals to the y, kx squared plus 2x minus k equals to kx minus 2. And then we have to simplify it to the general form. Kx squared plus 2x minus kx minus k plus 2 equals to 0. So it's kx squared plus 2 minus kx, and then plus 2 minus k equals to 0. So that means this will be A, this will be B, and this will be C. So D is smaller than 0. So B squared minus 4AC smaller than 0. So 2 minus K squared minus 4K times 2 minus K smaller than 0. We expand this, 4 minus 4K plus K squared minus 8K plus 4K squared equal smaller than 0. And then we have 5K squared minus 12K plus 4 smaller than 0. Can we factorize this? This is 5K, this is K. 4 is only 4 times 1, or 2 times 2. So I choose 2 times 2. So To produce negative 12, it's negative 10 and negative 2. So negative 12. So from here, k is 2 over 5, or k equals to 2. But since we are looking for the negative region, using the line number, we have 2 over 5 and 2. So the sign will be plus minus plus. And the smaller than 0 region is the middle region. So this is blank dot. So that means the k should be between 2 over 5 until 2. That's it. Number 5. Express 16x squared minus 24x plus 10 in the form of. So we're completing the square with 4 inside the bracket. So we cannot factorize this form. So we have to see the 16 as the square number. The square number of 16. So it is the bracket minus and then plus 10. So I prepare the room first. So 16 is 4x. 16 is 4 squared, so the square number is 4. So put 4x there. And then negative 24. So it's negative. So negative 24 will be divided by 2 and by 4. So negative 24 divided by 8 is negative 3. So this is minus 3 squared. So we have 4x minus 3 squared minus 9 plus 10. So 4x minus 3 squared plus 1. So this is the answer. It is given that the equation 16x squared minus 24x plus 10 equals to k, where k is the constant, has exactly one root. Find the value of this root. So from the previous answer, for x minus 3x squared plus 1. So we can express this as 4x minus 3 squared plus 1 equals to k. It has exactly one root. So if we draw the quadratic function, that this is the intersection between the curve of this and y equals to k. So draw the 16x squared minus 24x plus 10. So from the equation, we can say that the line of symmetry is x, and for x minus 3 equals to 0. So x equals to 3 over 4. So that means the minimum point is 3 over 4, 1. So if you draw, it's around here, 3 over 4, 1. 3 over 4, 1. So it will be like this. Now, this equation, it's about the intersection between the curve and the line y equals to k. So that means we have to find in which position that the intersection of these two lines, the curve and the line, only has one solution. So it's supposed to be passed through the minimum point. It has one solution. Because if you put it here, it will be has two solutions. If you put somewhere here, there is no intersection point, no solution. So that means it's supposed to be at the minimum point. So that means the k here, it should be the y value. So equals to 1. So that means we have to find the solution of x. So the solution of x is the intersection point. So one root is the intersection point. So that means the x is 3/4. Six. A curve has equation and a line has equation where k is a constant. Show that for all values of k, the curve and the line meet. So here we have to find the intersection formula. Yeah? So y1 equals to y2. So 2x squared minus 3x plus 1 equals to kx plus k squared. And then we have to reduce it to the quadratic equation. So 2x squared minus 3x minus kx plus 1 minus k squared equals to 0. And then we classify the term. So 2x squared minus 3 plus k x plus 1 minus k squared equals to 0. And we have to show for all values of k, they are met. So that means we can see it from the discriminant. If they meet, that means the discriminant should be greater than or equals to 0. But how do we express this as the positive discriminant values? So take the discriminant. So the d is b squared minus 4ac. So the b is negative 3 plus k. I put the bracket here, square, minus 4 times 2 times 1 minus k squared. So I can just do 3 plus k squared minus 8, 1 minus k squared. So I have 9 plus 6k plus k squared minus 8 minus positive 8k squared. So we can simplify this into 9k squared plus 6k plus 1. And we can change this into the completing the square form, since 9 is the square number. So I can prepare the room. So 9k squared become 3k. And then the 6k will be divided by 2 and 3. So it's divided by 6. So plus 1 and then minus 1 squared. So it's equals to 3k plus 1 squared. That's it. Now, the discriminant is in the form of 3k plus 1 squared. So that means for all values of k, the square number 3k plus 1 will be always positive. So it will be always greater than or equals to 0. That is the square number. So it's always positive. II. State the value of k for which the line is a tangent to the curve. And find the coordinates of the point where the line touches the curve. So when it says the tangent, that means we can have that the discriminant is equals to 0, because tangent means only one intersection point, one solution. So that means the discriminant now is equals to 0 because it's a tangent. So 3k plus 1 squared equals to 0. So 3k plus 1 equals to 0, k equals to negative 1 over 3. So this is the value of k so that the line is the tangent to the curve. And then find the coordinates of the point where the line touches the curve. So we have to solve the equation. So we put the k equals to 3 to this equation. To this. Replace the k to the equation. It becomes 2x squared minus 3 minus 1 over 3x plus 1 minus negative 1 over 3 square equals to 0. So it can be simplified into 2x squared minus 8 over 3x plus 1 minus 1 over 9 equals to 0. So 2x squared minus 8 over 3x plus 8 over 9 equals to 0. So I can multiply everything by 9. So it's 18x squared minus 24x plus 8 equals to 0 divided by 2. So 9x squared minus 12x plus 4 equals to 0. And then we can factorize this. So it's 3x minus 2 and minus 2. So it's equals to, that means, so x equals to 2, x equals to 2. So the answer is only 1. So x equals to 2 because they are the same. And y should be equals to, we can put into one formula. I can use the curve 2 times 2 squared minus 3 times 2 plus 1. So equals to 2 times 4 minus 6 plus 1 equals to 3. So the coordinate of the intersection is 2, 3. Showing all necessary working, solve the equation for x minus 11x to the power of half plus 6 equals to 0. So if you see this kind of question, you have to say that there is a pattern in here. This is x and this is x to the power of half. So we can express this equation in the form of quadratic equation. So for x minus 11x to the power of half plus 6 equals to 0. From this equation, we can see that there is a pattern that can lead us into the quadratic equation. So we can express this as 4x. X is the x to the power of half squared minus 11x to the power of half plus 6 equals to 0. By using a substitution, so let y equals to x to the power of half. So we will have 4y squared minus 11y plus 6 equals to 0. So replace x to the power of half with y. And then now we solve this into a factorization. So this is, I try 2y and 2y. And to make 6, I can have 2 and 3. Cannot yet. So that means this is 4, this is 1. And This is negative 8, negative 3. So it's negative 11. So that means y equals to 3 over 4 or y equals to 2. And then we replace back. Y is x to the power of half. It's equals to 3 over 4. So x is, we square it. So it's 9 over 16. And from here, x to the power of half equals to 2. So x equals to square it equals to 4. That's it. So this is the answer. Number 8. The function f is defined by f. Express 7 minus 2x squared minus 12x in the form of a minus 2x plus b squared, where a and b are constant. So that means we have to express in the completing the square form. So I will rewrite this as the negative 2x squared minus 12x and then plus 7. And see on the first two terms. And then we can have, I can factorize the negative 2. So this is x squared minus plus, yeah, plus 6x plus 7. And then I just do the completing the square form. I prepare the room. So this is x, and plus 6x become plus 3 and minus 3 squared. So I will have negative 2x plus 3 squared minus 9 plus 7. So it's negative 2x plus 3 squared plus 18 plus 7. So it's negative 2x plus 3 squared plus 25. So 25 minus 2x plus 3 squared. And then I state the coordinates of the stationary point on the curve y equals to fx. So again, from the equation, we have 25 minus 2x plus 3 squared. So from here, we have the line of symmetry, x equals to negative 3. And from here, we have the vertex, or the maximum point in this case. How do I know that this is maximum? Because the curve is negative x squared in here. Yeah, negative 2x squared. So that means the shape will be facing down, since the ax squared plus bx plus c, and the a is smaller than 0. So that means the stationary point here is negative 3 and 25.